Hello everyone. In this video we're going to look at how a computer works. We're going to look at the major components of a computer system and how they fit together. So let's go ahead and jump into the details. In this presentation, first I'm going to give you an overview of all the components and how they logically fit and flow together. And then we'll drill down into some of the subcomponents and look at a little bit more details of each one of those. And those include the motherboard, the CPU or central processing unit, RAM or random access memory, the system bus, input-output ports, the video controller, and the hard disk unit. So let's go ahead and look at the overall flow of all the components and how they fit together. So now let's go with an overview of all the components. The first component I'll start with is the motherboard. And the motherboard provides a structure for the computer where all the components plug into. On top of the motherboard sits the power supply, which gives power to all of the components in a computer system, and these are distributed by the motherboard, which gives it that structure. The next thing I'll talk about is the system bus that provides all the data communication for all the components, and this is integrated into the motherboard. And the system bus is synchronized with the clock, and this is in terms of the speed or the frequency that the computer cycles, and this is in terms of gigahertz. The next thing I'll talk about is the central processing unit, or CPU, which is really the brain of the computer and provides all the mathematical processing. Right next to the CPU is the input and output ports, and it provides components, communication to any kind of components such as a printer or a keyboard, and is generally done via serial ports, but there are also other methods that are available through input-output ports as well. The system memory, or RAM, is the next component I'll talk about, and that provides all of the storage for programs that are executing. And this is temporary storage. If you lose power, you will lose what is ever in system memory. So it's really kind of an ephemeral kind of storage. It's not designed to be long-term storage. Next I'll talk about is the disk controller, which interfaces to the system bus and then interfaces to long-term storage devices such as hard disks or DVD drives or any other kinds of long-term storage. The next component really is then the video controller, which provides the interface to the monitor. And in most cases these days it's an LCD high definition monitor, but that has definitely changed over time. So that really represents the components kind of from end to end. There are other pieces of the computer, but these are the kind of vital things that provide most of the functionality of the computer system. So now let's drill down and look at a little bit more details about each one of these major components. So now we're going to look at these components in a little bit more detail. The motherboard has mounting points for all of the components, and so if you look at this example over here, there's some expansion slots that allow you to plug in cards to do various things. There's also, you can barely see it here, but there are also slots for the memory sticks or memory chips that plug into the motherboard as well. Motherboards also include a battery to maintain the system clock, and that's the clock for date and time. So when your computer is turned off, it will retain the correct date and time. I've already mentioned the slots for memory as well as the expansion slots, and some older motherboards also have a mounting point for a central processing unit or CPU as well. Typically these days more modern motherboards have them soldered directly to the motherboard, and there's not a removable slot. At one time motherboards had the concept that you could perhaps upgrade your computer with an improved chip, but I think those days are long gone. But this represents the major functionality of the motherboard. Let's go ahead and look at the next component. The next component we'll look at is the CPU or central processing unit. Again, the CPU is the brain of the computer and it performs all the numeric calculations. So in terms of sizing for CPUs, they come in bit sizes. Common these days are 32 and 64-bit sizes. 64 is actually more common in today's market. As we go in the computer history, this number has changed. It used to be common for 8-bit and 16-bit CPUs, etc. But now 32 and 64 are the standard. Some of the major manufacturers for central processing units or CPU chips are Intel and AMD. There are other manufacturers like Motorola and some others that manufacture specialty chips. But in terms of components for personal computers that most people use. Intel and AMD are the major players in that market. Speed is a combination of clock speed and the number of cores. So a core allows a CPU to do multiple things at one time. So instead of having multiple CPU chips on a motherboard, which would be very complicated to do all that wiring for the system bus and everything else, the concept came about of having multiple central processing units on one chip, and those are called cores. So the more cores, the better, the more work you can do at the same time. So common numbers of cores for home computers are 2 cores, 8 cores, up to 16 cores probably for a really high-end home machine. And then for server computers, the numbers can go way up from there to a ridiculous number of cores, hundreds of cores for cloud-based systems now that you can provision over the internet with vendors such as Amazon or Microsoft Azure. So again, the more cores, the better. Common sizes for CPU, 32 and 64-bit. And the major manufacturers are Intel and AMD. So let's go ahead and look at the next component. So the next component we'll look at is system memory, or RAM, for random access memory. This is the main memory for the computer for program, storage, and execution. And these are delivered as chips that plug into slots on the motherboard. We showed really in the previous slide what those slots look like. In this slide, you'll see clearly how these sticks of memory plug into these slots, and they typically, on a home computer, you'll have maybe 2 or 4 of these where you can plug in different sizes. So these can come in increments of 4 or 8 or 16 gigabytes in terms of memory, and you plug these in to get a different capacity on the machine. So the machine will have a limitation to the maximum size of that particular chip, and then the number of slots. So the maximum number of size times the number of slots is the capacity of that machine for memory. So home computers come in different configurations, and again, these configurations grow every year in terms of memory as machines get bigger, cheaper, and faster. And typical sizes for home computers would be, anywhere from 4, 8, 16, or maybe even 32 gigabytes for a high-end machine. And again, server computers can go up way higher than that, particularly those, again, that are provisioned in the cloud with Amazon AWS or Microsoft Azure or the Google Cloud. But this is the basic concept for home computers and the motherboard, that it has these slots that you can plug these chips into. I should note that the architecture for notebook computers is generally different than this, and they're typically not as easy to expand. They're built more for being compact, having a much lighter footprint in terms of size, and so typically notebook computers are not as easy to upgrade with memory as their desktop equivalents. So let's go ahead and move on to the next component. So the next component we'll talk about is the system bus, and again, in a previous slide I explained that this provides all the communication for all the computer components for the data moving in and out of all of these components. And it's really based on the size of the CPU, so you'll either have a 32 or 64-bit system bus according to the size of your CPU. And again, it's synchronized with the system clock so that it synchronizes all those operations in a computer system, so everything works on a cycle together in a coordinated basis. So every cycle of the clock, the CPU does work, and memory moves across the system through the system bus in a coordinated fashion. So that's really it for the system bus. It's really integrated into the motherboard. So let's go ahead and take a look at our next component. So the next component we'll look at are input and output ports, and pictured here are the most common types of ports, or universal serial bus, or USB ports. There are other kind of ports as well, such as FireWire, Ethernet, others, but the most common is USB, and pictured here is a USB 3.0 port. Some of the standards have changed over time. There was a USB 2.0, and now there's a USB 3.0. It's gotten faster and more reliable over time, but this is a very common way for computers to communicate to things such as printers or other external devices, speakers, a microphone, you name it, you can plug it in, and most of these have a USB interface. So let's go ahead and take a look at our next component. The next component we'll look at is the video controller, in some cases a video card. So notebook computers typically have these integrated into the motherboard to save space. Also, some desktop computers may do that as well that have a smaller footprint, but larger computers may have a video expansion card. That's what's pictured here. This is actually a particularly really old card since it's a VGA interface, which is quite a bit older. And gamers and their computers will use high-end cards for really high performance graphics so that they can really get that high response time and high refresh rate. So that's really the video controller card, and it provides the interface to an external monitor, which in most cases these days is some type of LCD HD monitor. The last component we'll look at is the hard disk in the computer, and this is used for long-term storage of data and also programs so that before they're loaded into system memory they'll reside on the hard disk as well as the operating system. So these are sized in gigabytes or terabytes. There are really two types of drives these days. There are mechanical drives, which is pictured here. So there's a spinning platter and a spindle, and these drives are much cheaper than the other type of drive, which is a solid state drive. Solid state drives, or SSD drives, are the newer type of drive. They're typically smaller, but they are cheaper, they're more expensive and more reliable, but they typically have less capacity. So a lot of desktop computers may have a system drive that's an SSD drive so that it boots quickly and runs quickly, and then as an auxiliary storage have a mechanical drive that has a much larger capacity where you can have longer term storage. So you may see a mix of these. Most notebook computers these days are shipping with SSD drives because they can be much smaller and they are more reliable. So that's really it for our tour of system components. Let's go ahead and go to the summary and wrap this lesson up. In summary, we've looked at all the major components of a computer. The central processor unit is the brain. It performs all the numeric calculations. System memory, or RAM, holds executing programs. Input and output is done via serial ports that are typically USB ports, and the video controller communicates with your monitor. So these are all the major components and how they fit together in a typical personal computer. So that's really it for this lesson. Thank you so much, and I'll see you in the next lesson. Bye-bye. Much for your interest in this video. If you like this video, please click the thumbs up button. Also, if you'd like to see more material like this, please consider subscribing to my channel. That's really it for this video. Thanks again. I'll see you again soon. Bye-bye.